Okay, so hello and welcome back to another Unity tutorial. In this one we're going to be doing part 2 of Tracer. We're going to be spending the entirety of this video with the recall ability because it's got quite a few nuances to it. It's the most complicated ability that I've done so far, you know, compared to like Genji's dash and wall climb and stuff. It's more complicated than that, and obviously more complicated than Tracer's blink. So I decided, obviously since it's more complicated, I'd create it before the video to make sure I, you know, sort out any problems so I don't get them on the recording. And then I've got it ready now to show you, so then I'm gonna show you in a second, and then once I've done, I'll delete the code and remake it with you guys. So this is what it looks like. So here I am, and I did the scene view on the left so that you can see the raycasting I'm doing, or the line drawing, so you can kind of see what's going on. So as I walk around, I've got this trail following me, and then obviously Tracer's recall has a maximum time. It takes you back 3 seconds, so that line at the end is where I was 3 seconds ago. I can't remember if I actually made the numbers right for that, but I can tweak those if I need to. And the point is, it remembers where I was at that time, and if I jump, obviously it gets me in the air, and as I turn around, it's actually storing the rotation as well. So if I press E to recall, I actually take that path back all the way back to the start with the same rotation and position as I was, and obviously it starts again. And even if I dash, if I use my dash, it still works. So then I can go back and zoom around and back like that. And if I don't actually, I can't jump on this box because I don't have a double jump or a climb, but the point is, it remembers where you've gone and what rotation you had. So if I actually spun around loads and spun around and then pressed E, I'd spin around loads back. So the point is, it remembers what you did. Now the thing is, let's say if I go quickly to my Tracer thing, here are the settings. You don't actually need to know. This is just the list of things it's storing. It doesn't need to be a 20 element list. You could have it less or more. It's up to you. And then this 0.2 is how often it actually records data. So obviously it's going to be straight lines because no matter what, it has to be straight lines. But if I change this max data to like 40 and this thing between to 0.1 or something, now you see it stores for the same amount of time as it just did, but it's much smoother. When I jump, you get a much smoother path, and so on. It's really up to you to tweak those numbers, but the point is it works, and we're going to get into how to make this. So before we start, I want to thank my patrons. So thanks to Michael Forborm and Remy Baldwin for their donations on Patreon this month. If any of you want to help support the channel and the community, then the link in the description below. You also get access to these project files and any other projects that I work on from now on, basically. So if that's an incentive that makes you want to help, then, you know, please go ahead. But it doesn't matter really. Let's just get into the video. So what we need to do is, because I did some stuff off camera, is go back to the player camera controller and just remove some stuff that I did off camera, which I'll redo with you guys when we get to it. So let's start fresh. We're gonna go to the Tracer recall and just delete it. Actually, no, I won't delete it. I'll just clear all the code over in. So let's just select all of these functions and start again. So back in Unity, what do we have? Well, we have just an empty script on the Tracer prefab. Just make sure you got it on there, otherwise the ability is not going to work because it's not going to actually have code running on it. So we want it on Tracer. Now, what do we need? Well, I first of all want to go through the variables. So what we're going to need to know, how many kind of points of positions and rotations we want to store. The higher this number, obviously the more memory it requires, but the better, like, smoother experience it is. So because if you only had like 2, for example, you could only go in a straight line. The more you have, the more curved it is. So it's up to you. So I'm going to say max recall data equals, I'm going to set it to a default of 6. 6 is okay. It doesn't have to be 6, up to you. Then we're going to have a, let me zoom in a bit, float. This is how long we wait between getting new data, because ultimately these two numbers combined gives you the actual, you know, how far back in time you go. So if we put seconds between data, I looked up on the wiki earlier, I don't want an F there, sorry. I looked up on the wiki earlier, Tracer's recall sends you back 3 seconds over 1.5 seconds. So the actual teleporting you back is 1.5 seconds long, but the time you go back to is where you were 3 seconds ago. So recall, recall duration. That is, I think it was 1.25 seconds. I actually can't remember the exact number, but it doesn't matter, you can tweet that. So that's how long it takes us to get back there. And if you do 0.5 times by 6, you get 3. That means it takes 3 seconds to get, 3 seconds is how much you store, how like far into the past. So basically, the bigger either these numbers are, the more you store, but the smaller this one is, the more precise it is. And the bigger that is, the more precise it is, because you get more data. So it's up to you to tweak those numbers to your heart's content, but let's get into actually making it work. So we need to store reference to the player camera controller, because once we have like got to the end, or while we're moving basically, we want to lock rotation. We don't want the player to be able to move the camera and have that like be controlled by the player. We want the rotation to be controlled by the actual recall ability. So let's just get reference to the player camera controller. We want to store a boolean for whether we can collect recall data, because we only want to collect recall data whilst we're not recalling. So if we are recalling, we don't want to like record where we are, because you only want to know where you are when you're not recalling. So can collect recall data is equal to true by default. If you didn't set that, or you set it to false, then you won't be able to recall all, because it'll be started off as false. You need to start it off as true. And then we can store a float, which is like the current data timer. That's what I call it. I couldn't think of a better variable name. So this is how long through the current piece of data we are. This is just like the blink we made last video. In terms of we stored a timer on how far through the current blink recharge we are, and when it gets to a certain point, we increment how many dashes we've got and then reset that back to 0. So it's like a timer that stacks things. So it's the same kind of system. We're stacking positions and rotations every 0.5 seconds, and this is storing how much we've currently done. Then we need to, well, we don't need to, but this is a nicer way of doing it. We should store our own private class in here called like recall data, just because it's better having like 3 variables like together rather than having them spread out everywhere. It would get a bit ugly. So we want a public vector free character position, a public vector free, quaternion, which is how rotations are stored in data, character rotation, and then another public quaternion for the camera rotation, because the player's rotation is only on the y-axis. It only spins around. If you look here, when we actually do looking with our mouse, the player only rotates on this axis, and then the camera rotates on the x-axis. So we need to actually have we need to store our rotation and the cameras. Technically, you could actually make these floats and just store the one that changes. But I feel like if I do it that way, I might get some problems, though it's probably more memory efficient. It's really up to you. And then we might as well make this system.serializable, so we can see it in the inspector when we're testing. It's just for debugging purposes. Once you know it's working, you could get rid of that and make this private. But for now, I'm going to make it serialized field private, so we can see it. We'll make a list of recall data, and this is ultimately what we're going to go through, and it's what we're going to go through and set our positions to as we are recalling. This stores where we were 1 second ago, where we were 2 seconds ago, where we were 3 seconds ago, and so on. This is the list of positions and rotations. Okay, that's all the data. Like, that's all data stuff done. Now we can write the logic. So we want a start method, which sets the player's camera controller to, and then we want to reference it. Now we could just make it a public variable and drag it in, but to be honest, it's always going to be in the child of the player, so we know it's in the children. So get component in children, player camera controller. So now we have reference to that for later. And in the update function, we need to actually do the setting of the data. So the first thing we need to say is current data timer plus equals time.delta time. Just like how in the recharge we need to add to a timer over time, that's how you do it. And then we need to say, well, if we can, because we made this boolean earlier, if we can collect recall data, then we want to check if we are at the next like increment. So if the current data timer, which is a float, is greater than or equal to the seconds between data, which is what we specify. If we've got to that point, then we want to record it. So the way we record it is by saying recall data.add, and then we should probably write a function for this because it gets a bit messy if you do it all in here. So we'll go down and we're going to write a function that basically returns where we currently are in terms of position, rotation, and the camera's rotation. We could write it in line here, but if we ever needed it again, it'd be a bit messy, and it's always nice just to make things into functions. So it's a private, and it's not a void because it doesn't return nothing. It returns a recall data. We'll call it get recall data. And then we want to return a new recall data, which is the class that we made earlier on up here. It has a position, rotation, and then the camera's rotation. So let's set all the variables. So we need to set the character's position to transform.position, the character's rotation, no, I need to use a comma, not a semicolon. Character rotation is equal to transform.rotation. And then we need to store the camera's rotation, so I keep using semicolons, okay. Camera rotation is equal to the camera controller, so camera controller dot transform dot rotation. And we don't put we put a semicolon there to end it. Alright, we're returning this object. Returns the recall data. So instead of writing all that in line, we can say get recall data. Then we go back up. I'm getting a bit lost. Alright, so yeah, we can add on the recall data, but the problem is, what if we've reached the max? Because we don't want to be able to go back forever. We need a maximum where, as we're adding on to the end of the list, we're removing from the front of the list. So if I get good old Paint, if we had like a list of values like 1, 2, 3, assuming these were positions, if we added, let's say the max was 4, as soon as we add a new value, we want to remove the first one, and if we add another 6, we want to remove that one, but we only want to remove it if it's at the max. So as well as adding, before we actually add, we should say if the recall data.count, so if the amount of data, the number of data we're storing, is greater than or equal to the max, then we want to remove. Which one do we want to remove? We want to remove the one at the beginning of the array, the beginning of the list. Whatever's at the front we want to get rid of, so index 0. Cool, and then .add puts it on the end, so it's cool, that works right. And then we want to reset, now that we've done this, the current data timer back to 0, so that we can start on our next stack. So this here is what handles the like storing of locations and rotations. So we'll put that into its own function called like store recall data. So that's what it does, it stores the recall data. I mean, it technically also like handles removing as well, but that's what we'll do for now. It makes it need to ping its own function. And then under here, what I did in my own example, which I guess I can do with you guys, we're gonna do a quick debug thing, which you should probably remove afterwards, but it's good for testing purposes. We'll make a for loop, so for tab, and it's I equals 0, I is less than recall data dot count minus 1. The reason we're doing this is because we want to draw a line between each of the positions, but once we get to the end of this loop, there'll be no other position to add it onto, so we need to subtract 1, otherwise we'll go too far and it'll say, nope, the next one doesn't exist. We only want to go up to the end, not past it, so debug.drawLine. We want to draw a line between recall data and I, because it's whichever one we're currently on, character position. So I want to draw it between that position and then the one after it. So recall data I plus 1 dot character position, character position. So if we draw lines between that and that, then that's what gives us the path. That shows us, we'll say, it's saying, all right, so for the first one, we'll draw it between, like, I'll do another Paint example, it's quite good. So if we had a point here, point here, point here, point here, point here, we're basically saying, all right, first iteration of the loop, draw a line between here and here. Next one, draw here to here. Next one, draw here to here. Next one, draw here to here. The reason why we subtract 1 is because at the end, if we didn't subtract 1, it would try and draw one from here to, and then we got nowhere to go. So we want to subtract 1 to stop it. Cool, and that's just for debugging. After this, after you've tested it and it all works, you can get rid of this. And then we want to wait for the recall input, so recall input. And then we're going to write a function just because it's neater, private void recall input. And we'll say, for now, obviously, as I go on with the series, I'll definitely want to make an input system, but for now, it's simple enough just to put input get key down. If we press the E key, then start coroutine, and we're going to make a coroutine called recall. And this is what handles the actual magic, doing everything. This is the complex thing. Now let's go put this right at the bottom. Private IEnumerator recall. Alright, so this gets a bit complicated. Hopefully you can not carry on along, hopefully you can follow along. So what we need to do is, first of all, we need to lock the camera's rotation. We don't, by lock the rotation I mean lock the input. We do not want to be able to rotate the camera while recalling. So player camera controller dot lock. I haven't written the lock function, that's a good idea to do that. Alright, I'll pass in true and then I'm going to go and write it. So if we go to the camera controller, let's make a function. Public void lock, and we'll pass in a bool like should lock. And here we need to store in this class whether we are currently locked or not. So let's just go and add a private bool is locked equals false, because by default the camera's fine, it's not locked. And on here for the camera, we need to say if is locked return. Which all that means is whenever we go to rotate the camera every frame, if the camera's locked, then we just don't do this code, we return, which leaves and doesn't do the rest of the code. You should have met return enough to know how to use it, so basically we're saying if we're locked, return from this function, don't continue, we don't want to rotate. Cool. In the lock, this is where we want to basically say, well, is locked is equal to should lock. Right, so the private variable we're going to set equal to the thing we've passed in. But then we want to handle something. We want to say if not should lock, which basically is saying, you know, if we should unlock, if we've gone back to controlling the character, we want to set our current direction and smooth velocity. We want to reset them, because otherwise what will happen is as soon as we unlock it, it'll flick back to the rotation it was when we locked it. We want to set it to whatever it is now. So we want to say the velocity, smooth velocity, is equal to a new vector 2. And if we just leave this empty, it's the same as doing 0, 0. So that's just saying, you know, get rid of the velocity. And then we want to set the current looking direction equal to a new vector 2. But these values, if we look down here, the x value in this vector 2 is what we're going to set the player's rotation with. The player's rotation is that. So we want to go and first of all set the first bit to player transform, which we have reference to, player transform dot Euler angles. Now the reason we use Euler angles is because rotations are normally in quaternions, which is a certain data type for storing rotations, but we want it in a vector free, or a vector. We want to get a float out of it basically in vector form. So we want to refer to the Euler angles or the local. They technically both work. For what we're doing, it doesn't matter because this is the root object, so the parent is, but basically local just means relative to its parent. Euler means relative to the world, but the world is the parent because it's like there's no parent of the player, it's just in the world. So it's up to you. I'm going to go with local, it doesn't matter. And then we want to get the y, because as you remember from earlier, the player rotates on his y. If you look up here, the y is what's changing. So that's the first variable. Then after that, we've got the y. Keep in mind, this y doesn't have to be the y of the vector, and so on. Like, we're using the y for that. I mean, that's kind of confusing. We could flip it around. For now, I'm just going to keep going. We want to now set the other part of the vector, the y, which is used here, to the same thing, but for the camera. So this is the player. We want to do this for the camera. The camera's up and down, which is the x. So we're going to say transform dot local Euler angles dot x, and we actually want to make this minus, because if you remember, our camera, we use minus down here as well. It's just because when we look up, this rotation goes negative, and when we look down, it goes positive. And obviously down's usually negative and up's usually positive, so we need to inverse it so we don't get any problems like that. And that's actually the camera code done, so let's get rid of that. Cool, so now we can lock, and we got no errors there. So we lock the camera. got to continue recalling. So can collect recall data is false. We don't want to collect recall data while we're recalling. Next, we need to calculate just a quick number, a float, for how long we get for each bit of data. We know how long we're getting total and how many. Oh wait, actually, if I look up here, no, we could just use this seconds between data value 0.5, but it's safer to calculate a new variable here. Most of the time it will be 0.5, but you could actually recall technically before you've got the max number of recalls, in which case this would go weird. So we want to say seconds for like each data is equal to the recall duration, which is what we specify, divided by how many are in the list of recall data, like .count. This should be the max, in which case we could just, use the value from up there. But the problem is it might not be. Like if you, for example, say, oh, I want 20 pieces of recall data, and you press recall when you have 15, then the normal thing won't work. So this works always. So we're going to store that float. Then we're going to store a vector free for the current data player start pos. Now, when you're doing lerping, which is what we're going to get to, linear interpolation, if you want to get from one place to another in a specific amount of time, which is what we want to do, we want to get from A to B in a certain amount of time, this is the way to do it. So we're going to store our current transform.position. We're going to say a quaternion is current data player start rotation. These are getting long variable names, but they're very descriptive, so we won't get confused, is our rotation. And let's just duplicate that and change player to camera, and then camera controller dot transform dot rotation. So this is storing right at the start where we are, our rotation, our transform. And then we want to go between these values to the ones in our array of data. And then once we're there, we want to remove it and then go between where we are and the next one, and so on. So it's like, if we are here, let's say this is us, and we got to go to here, 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 here. We're saying, all right, this is where we are now, let's store that, and we're going to go to this last value in the array. And as soon as we get here, remove this, set this as our new location, and go to here. Once we're here, set this location, just get rid of it, go to here, set this new location, and go to here, and so on. That's what we're doing. So, while recall data.count is greater than 0, because we're going to keep going until we run out of things to go to, basically. So, while there's more than nothing, we're going to store float t, which is the time on the current piece of data, the current entry in the list. So that's equal to 0 when we start. And now we're going to say while t is less than this thing we've calculated, seconds for each data. While it's less than that, we want to plus equals time.delta time. Just like how we've got the counter over here, we're doing it here as well. And because it's in a coroutine, we have to say yield return null to make it actually wait at the end of this. But the actual logic will put it before the t. So what we need to do is we need to set our transform position to vector3.lerp. So obviously I've used lerp before. You pass in where you are now, where you want to be at, and a percentage as such of how far between those two numbers you want to be. So we want to go between our start pos and recall data, so that's the data. We want to go between the last value. To get the last value of the array, you do .count -1. That's the last value. .character position. Let me zoom out a second. Okay, so we're setting our position somewhere between this position and this position, so where we are now and the bit we want to get to. And then you need to pass it in, how far do you actually want to go between those? So let's just put these on their own lines. So we want to go by t divided by seconds for each data. So obviously if t is 0.5 and we've got 1 seconds, 0.5 over 1, anything over 1 is 0.5, so we're going to go halfway there. This value generally goes between 0 and 1, 1 being you're at the second position, and 0 being you're at the first. So as we go from 0 to 1, we're going from this position to that position. Now, let's say transform.rotation is equal to quaternion.lerp, and it's the same function just for angles. So you pass in the first angle, which is current data play.rotation, comma, recall data dot count -1 dot character rotation. Whoops, character rotation. There we go. Comma, t over seconds for each data. And then finally we want to do the same for the camera. So camera controller dot transform dot rotation is equal to quaternion dot lerp current data camera start rotation. And then it's the same thing. Let's just copy these two lines here, but just change the word camera rotation. Okay, so this is what's actually going to be changing our position and rotation over time. That's the meat of it. That's the main stuff. We've done most of it now. We're going to say like slowly make our position be the next one, slowly make our rotation be the next one, and the camera's rotation. And then this is going to loop for this bit's going to loop until we are out of recall data. But the thing is, at the moment, we're never actually removing any recall data. So what we need to do is we need to say down here, recall data dot remove at the last one. So recall data dot count -1. There's probably some built-in thing for just getting the last one, but that's the normal way to get it. And if you did have a built-in way, it's probably just doing that anyway under the hood. And what we actually need to do is this position. This is where we are at the start, but we actually need to reset it every single time we go between each of those like nodes, because otherwise we'll get some weird effect. So every time we've done a node, basically, once we've got out this while, it means we've completed a node, and then we're going to go to the next one. So we want to, I'm just going to copy and paste this, no point typing out. We want to set our position to the next one, the rotation to the next one, and the camera's rotation, current data player start. Oh, it's because I used the full words, rotation. Alright, so it's basically saying once we've got to a node, set it to where we are now, set it to where we are now, set it to where we are now, remove it and go to the next one. So this is the whole logic for it. Now all we need to do is basically say, when we're done, which is when we get out of this while loop, so that'll be right here, once we're done, camera controller dot lock false, so we're going to unlock it. And then we're going to say can collect recall data is true. Therefore, we can start collecting data again. Okay, let's go test it. So, I know this is quite a long video, but it is quite a complex mechanic, you know. In reality, if in Overwatch, they will have a much more complicated system, or maybe better, just a more intricate system for doing this, because it's a lot smoother than the way I've made it. They probably do other factors and other variables to make smoothing, but this works. So, obviously I've set the variables here. I'm just going to apply that to the tracer prefab. And let's go try it. So if I run around, you see we're drawing a line, and if I press shift, we're drawing a line. Obviously, as I said, it's very, you know, it's not a curve, it's a straight line. If I press E, I go all the way back. If I look up and walk over here and then press E, I end up going back and looking down. If I shift around and then spin and then press E, I spin all the way back. So it all works perfectly. And as you see at the bottom down here, it's actually filling up with all those. Now if you go into here, it stores current rotation for the camera and the character and the position. So each of these elements is just each of these kind of dots, each of these turns on the line, each of these vertices. So if we did want to make it more precise, then obviously we might want to have like 30. But the fact that I've increased it from 6 to 30, the fact I've timesed it by 5 means I need to divide this by 5, so every 0.1 now, to get the same duration. But as you see, it's much smoother, so if you want to, then you can do that. And now when I press E, smooth all the way back. So yeah, I hope you like this video. If it was too hard to follow along, obviously, you know, take it slow, go back. But also, if you do want access to the project files, and they are available on Patreon, and obviously the main reason I've done that is to help support me and give you something back for the support. Because I know some of you beginner people might not, you know, be able to keep up with this fully. But I hope you like the effect and, you know, how it works, and you see it in action. Try making your own abilities maybe. I'm going to continue with Tracer in one more video. I'll create the input system I've been talking about, and I'll probably make the ult in that video because the ult's not very difficult. So stay tuned for that video either tomorrow or the day after. But apart from that, thanks for watching and goodbye.